guys, welcome to the video on linear versus exponential models. And we started talking about this today with that Gini problem, but now we're going to get into other types of problems. So you should have kind of been a little familiar now with linear versus exponential. Let's start with linear. A model has linear growth if the same thing is being either added or subtracted to your initial amount over a certain period of time. Okay, so if there's an addition or subtraction pattern, it's a linear model. And you guys know lines very well. You know it's of the form y equals mx plus b, where m is the slope, also known as that increase or decrease, and b is the y-intercept, which is the initial amount or the starting value. Either way, initial amount or starting value. And then here's an example. You start with 50 bucks, you earn an additional 100 every day at work. Write the model. So we know it's y equals mx plus b. The m is the amount that it's increasing or decreasing by. That's $100 every day. And then the b is whatever the starting value was. You started with 50 bucks. All right, so that's how you write a linear model. On to exponential models. If something has exponential growth, then the same amount is being either multiplied or divided to your initial amount over a certain period of time. And the general form for an exponential model of multiplication or division is y equals a times b to the x power. That's that exponential part. And then let's go over what those things stand for. The a is the initial amount, and the b is the number that's being multiplied or divided. So the number multiplied or divided. I don't have room to write it all. And then a quick example. Can you write this exponential model? You start with $1. That's the starting value A. Every day after that, you double. Double means times 2, and that would be the B. So just plug it into the formula. Y equals A times B to the x power. Starting value is 1, you're doubling it is 2. All right, so just a couple examples about using these models. So number 1 down below. Whoop. All right, here we go. A library has 8,000 books and is losing 3 books a year. So first of all, is it linear or exponential? And hopefully you guys are saying, well, if you're losing 3 books a year, wouldn't that be a subtraction? And subtraction is one of our linear models. Okay, so you're going to circle linear. And then it says, why did you choose that? Because of the subtraction pattern. Okay, B says, can you write an equation? So 8,000 books would be the starting value B, and losing 3 books a year would be the slope M. All right, and then let's just plug it into our formula. So it's y equals mx plus b. Y equals m is 3, but careful. If you're losing, it's going to be negative 3x plus b, which is 8,000. Make sure you make your slope negative if you're subtracting. And then we also need to define our variables. What do x and y stand for? So in this problem, x is each year. So X is years and Y is the books. So depending on what year, how many years have passed, that's how many books you have. And then C says, can we use this equation to find a future value? What if, how many books do you have after 10 years? You just plug in 10 for X. All right, so it's going to be -3 times 10 plus 8,000. That's 7,970 books. All right, so that's a simple linear model. Okay, let's try one exponential. So let's do 2. Why not? All right, so read the story. Is it linear or exponential? Bank account starts with $10. Every month the account is tripled. Well, tripled means multiply by 3. And if it's a multiplication pattern, then it's exponential. Why? Because of the multiplication pattern. That was a sign that it's exponential. All right, let's write the model. Remember, the general form is a times b to the x power. So let's see what a is. A is the starting amount, starting with 10. B is the multiplication or division factor. So tripled means 3, and then to the x power. Okay, so that's our model. Define your variables. Let's write what X and Y stand for. X is the month, and Y is the money. So depending on the month, Y tells you how much money you have. Okay, and then C says, well, after 6 months, how much money do you have? Well, if months is X, we're going to plug it in and calculate. So we're going to do 10 times 3 to the 6th power, $7,290. And that's it. All right, we're going to skip 3 because I think one of each is enough. Thank you for watching.